to continue with our discussions, we go now to the examination of cultural characteristic, physical requirements and chemical requirements for bacterial culture, and culture media, chemically defined media, and complex media. Okay. Microbial growth refers to the number of bacterial cells, not the size. Take note. Microbe grows thousands and even millions. So total number of bacterial cells are usually proportional to the number of cells in the population. So usually when you do the culture or microbial growth, it depends the total number of bacteria, example Staphylococcus aureus, usually depend in the number of cells in the certain population or in a certain culture media of the bacteria. Okay. So requirements for the growth were physical, temperature, pH, and osmotic pressure. So in temperature class, microorganisms grow well in normal temperature favored by higher animals. Usually, bacteria tends to live in room temperature or in normal body temperature, that is almost 35 to 36 degrees Celsius. And there are some bacteria that are capable of growing in extreme temperature or cold or even extreme heat. Okay. So microorganisms are divided into three groups of bases for preferred range of temperature. We have psychrophiles, cold-loving microbes; the mesophiles, moderate temperature-loving microbes; you have thermophilic, the heat-loving microbes; and hyperthermophiles are microbes that produce and grow in higher temperature. So even in higher, try to see even in higher temperature class that is above the uh, boiling point, or even bacteria that lives, in example doon sa Mambucal, diba, that is volcanic, and there is a spring there that boiling water. So there are also some hyperthermophilic bacteria that lives there. Okay. So examples of temperature classification: psychrophiles or psychrophilic bacteria, they have -5 to 20 degrees Celsius. So we have Pseudomonas fluorescens, actually secret truth ang tawag sa kanila. Okay. Mesophiles growth range 20 to 45 degrees Celsius. The E. coli, Micrococcus, Sriracha marescens, Saccharomyces cerevisiae. Okay. Optimum temperature is almost 37 degrees, and there are a lot of bacteria that lives in this range, or the mesophiles. And even thermophilic bacteria growth range of 35 to 80 degrees. The Bacillus sterartomophilus, and optimum temperature is approximately 55 degrees Celsius. And we have thermophilic bacteria, growth range of above 80 degrees Celsius. Optimum temperature, it varies or variable. So archaea such as Pyrolobos bacteria these are examples grown in the lab with a specific characteristic based on their temperature. So pH, most bacteria grow in pH 6.5 to 7.5. So few bacteria grow in pH below 4. So that is almost acidic. So the term there is acidophiles, or acidophilic bacteria are characterized that growth in acidic environment, and if they are exposed to alkaline environment, or alkalinity will inhibit bacterial growth, because their nature, they live in a nature wherein considered to be acidic environment. So example is Acidobacterium phylum of bacteria, the Aciditayo Bacillus or Bacillularis, an order of Proteobacteria. Example is the A. ferrooxidans and A. thiooxidans, the Thiobacillus prosperus, T. acidophilus, T. organoborus, and T. coprinus. So Thiobacillus for T. We have Acetobacter, aceti, a bacterium that produces acetic acid in vinegar from oxidation of ethanol. So take note, Acetobacter aceti. So that's why the acetic acid name is derived from that aceti. We have the Alicyclobacillus, a genus of bacteria that can contaminate fruit juices. Okay. So mga fruit juices, usually these are acidic yun. For example, ang calamansi juice, lemon juice, usually these are Alicyclobacillus. So osmotic pressures, microbes requires 80 to 90% water. So high osmotic have the effect in removing necessary water from the bacterial cells. Usually hypertonic solutions where there is higher amount of solute inside the cells of bacterial cells. So the cellular water passes through the cytoplasmic membrane to the high salt concentration. This is salt, not slot. That is salt concentrations. Okay? Osmotic loss of water causes plasmolysis and shrinkage of bacterial cells. That's why with this hypertonic solution class, it will cause damage to the bacterial cells because of the higher solute concentration wherein water tends to permeate inside the bacterial cells, and the bacterial cells will burst or lysis, okay, because of the higher salt content or concentration. Effect of osmotic pressures. So osmotic pressure is a pressure exerted in bacterial cells by their environment. In isotonic, this is normal. Okay, so the concentration outside and inside is almost the same. While hypertonic, there is a higher concentration inside the cells, so water tends to leave outside, and then there is a bursting of the cells. So hypotonic bacterial cells gains water because there is a lower amount of lower amount of salt concentration or solute. Then some opportunistic pathogens or facultative halophiles, we have Staphylococcus aureus, can colonize the skin.